Good day, everybody. Today I want to look at finding the infinite sum of n over 2 to the n without using calculus. And this is a way that was shown to me by Professor David Pengelly, now Professor Emeritus. And back when I was a grad student, I had mentioned, of course I knew how to do it using calculus, but I knew the result was known before the calculus method. And I had no idea how it could be done, and mentioned it to him, and he kind of thought for like a second or two, and then started drawing on the board, and came up with this method, which always impressed me, and I'm not sure if it's original to him, probably not, but anyway, so here it is. So let's see. So for the sum, we're going to make rectangles representing the area of each term. Let's see, and here we go. There's the first rectangle. So that's 1/2 and 1. There's the next term, 1/4 and 2. 1/8 times 3, and so you can kind of see what's going on. Note, I started the rectangle here at 1, and its height is 1/2, so there still was a 1/2 gap. The next rectangle has half that, and so there's half remaining, right? So it had 1/4, there was 1/4 remaining. Now that there's 1/4 remaining, the next rectangle has height 1/8. Half of what was remaining. So each rectangle is going to go half of what's remaining, but its length would be the numerator, and that's what we're putting down here. So let's see, n equals 4. So here we go. So this has 1/16 for the height, 4 for the length. There's 1/16 left. The next one will be 1/32 for the height, and 5 for the length. There we go. And so you can see this little gap is going to obviously go to 0 very fast if you keep taking half. Right now there's 1/32 left, and when n is 10, we'd have 1/2 to the 10th left, which is about 1/1000, 0.001. If n was 100, we'll have 1/2 to the 100 as a gap, which is around 1/10 to the 30th. And if you multiply that by the 100, just to get the area missing, right? The area missing is the n times the 1/2 to the n. Didn't mention, but you can kind of see the area I add is the same as the area left under what's been graphed so far. So n equals 100. We'd have 100 over 2 to the 100, which would be less than 1/10 to the 28. So I mean, that area is going to 0 very fast. So let's redo this a little here. Again, our first rectangle, the second, the third, the fourth, the fifth, the sixth, and you know, barely, probably can't even see the gap at this point. And definitely as we keep going, we won't be able to see the gap anymore. So, writing the rectangles that way, we'll get this set of areas, but now we'll read off the areas as, well, as if we did go all the way down. So then this has area 1 plus, and now each base will be 1. So 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1 over 32, and so on and so on. And that's a easily found geometric series, can be found easily without calculus. That sums to 2, and so that gives us our result. So there you go. The infinite sum of n over 2 to the n found without using calculus. Hope you enjoy. Have a nice day.